Hello, I'm Dr. Soren Maloney, and I'm a member of the Committee on Early Career Development, and I'm a freelance engineering consultant. I'm here with Dr. Amy Fleischer, who is a professor at the Mechanical Engineering Department at Villanova University in Philadelphia, and she's also director at NovaTherm Research Lab. I'd like to welcome Professor Fleischer, and thank you for joining us today.
It's my pleasure. I'm happy to be here.
What are some of the research problems that you are working on right now in your lab?
There's a lot of issues with energy in the world today, and the need to store energy for later usage is going to be something that's going to be incredibly valuable as we try to get into some alternative energy sources and being able to use them efficiently, such as perhaps solar energy, like a concentrating solar plant. So working on these materials in which we can actually store energy is the focus of what we're doing in my laboratory.
If this is successful, what is sort of impact that it would have on the lives of people in the world that we live in as it is now?
What we're hoping to see is that we can develop materials that will allow us to efficiently store energy. And if that happens, we're hoping for wider acceptance and wider implementation of solar energy. We'd really like to be able to use these energy storage materials towards more efficient behavior of energy.
Where do you see all of this heading?
What we're looking at right now is trying to manipulate these materials to improve their thermal behavior so that we can store energy more rapidly and discharge energy more rapidly.
What are some of the gaps in knowledge that you think engineers need to solve?
I think what we really need to concentrate on solving is understanding some of the fundamentals of this energy behavior at the nanoscale. That's where we're still discovering what's happening as we use different shape materials, as we use different types of materials, what happens at the interfaces between these materials from particle to particle and from particle to bulk material.
What are some of the problems you think that researchers like yourself still need to work on, still need to address?
I think a lot of the things that still need to be answered again are the issues between the interaction between individual particles and how these interfaces affect each other. And some of the questions in the applied realm would be, how do we keep these particles in suspension? And what we have to deal with is keeping these particles from moving such that they would agglomerate into larger particles and drop out of suspension.
What are some things you wished you had known before or when you started out in your career as a researcher?
What I tell young engineers and young researchers is that you have to be persistent, you have to be curious, and you cannot be afraid to ask questions. I think too many young engineers feel that if they ask questions, they're going to reveal the fact that they don't know something. But the secret is all of us don't know.
Don't know.
We don't know.
Correct.
So we really have to ask the questions, and that's what research is all about.
Yeah. For a young, upcoming, early career engineer, what sort of training and skills do you recommend?
Well, definitely to be a top-level researcher, one needs to have a PhD degree. And that is true, whether you want to be an academic researcher or whether you want to be an industrial researcher. There's a lot of people doing top-level research, wonderful research, who work in industry.
Industry, correct.
And there's plenty of roles for PhDs in industry. So, and then beyond that credential, what you need to be aware of is that your learning doesn't stop when you get the degree.
Professor, I just want to say thank you. It's a pleasure having you. Thank you.
It's been really just wonderful talking to you.